So to implement this model, so today's session would be devoted at how to implement this algorithm. So when you start uh, implementing this model, so first thing you have to take care is your vocabulary, or the number of words that you want to recognize. So all the number of words which you want to recognize in a particular document. So so all these words, you have already a corpus of that. And another thing is the number of classes that you want to recognize is. So it could be binary, relevant and non-relevant. It could be multiple classes. So this vocabulary and this you have already fixed. Now you got a training data. So in the training data, first you calculate the prior. So this is the prior information. So prior is the probability of any class. So let's say in the training data there are n documents. So for each class you calculate this probability. So if there are 3 classes, probability of C1, that how many documents which belong to that particular class C1 divided by the total number of document. Similarly, you calculate the probability of C2. So number of documents which belong to C2 divided by the total number of documents. So since you got a training data, so it is easier to calculate this prior information. And many times it is assumed to be equal. So if there are 3 classes, it is assumed to be equal. So that is also in some implementation it is done. But this can be calculated if the training data is given. Now for each word in your vocabulary. So let's say your vocabulary has k words. So for each word in that particular class, suppose in that particular class, let's say your total n is 1000 and C1 is 200 document, C2 is 600 and C3 is again 200. So your probability of C1 is 200 by 1000. Now for each word, let's say X1 is the first word, probability of X1 to be in C1, let's say J is 1. So number of documents which are in C1 is 200. So in how many documents X1 comes? Let's say out of these 200, in 70 it comes. So out of 200, 70 it comes. So we calculate probability of Xi for each word in each class in this way. So after training, after learning the model, now we know the probability of each word in each class. So this is the prior information. This is called the likelihood. So likelihood is the probability of each word in each class. So that is also calculated. So these two things are calculated from the training data. Since these are very easy to calculate, so it would take very less time to calculate this thing. Now problem with the maximum likelihood, this we have taken assumption that each of these words are independent. So if there are 5 words in a document, so we have assumed that we will multiply their probabilities. But we know that there are more than 5, usually there are 100 of words. So multiplying 100 of probabilities, so that is very cumbersome and that may overflow your floating point value. So, and further, there could be one of the word which is not available in that class. So probability of that, let's say particular word T, X5 is 0. So that 0 will also may come. So two problems in multiplication is, one is probability of some word can come to be 0. Second problem is overall multiplication of these many probabilities is also may cause floating point overflow. Now to avoid first zero problems, what we can do is uh, we will add some 1 here, and we will also add one k value here. So this k is equal to the number of value of xi, and this one is taken because even if there is no document where this particular word exists in any in that particular class, if even if this n is 0, still there is numerator is 1, so that 1 is added to avoid the 0 value. So 0 is avoided by using this thing, but this is also added just to avoid overfitting. So this is equal to the number of words in your dictionary, so total number of words in the dictionary, so this is also taken. So these two are the uh, just to make the algorithm work, so these two modifications are being done. So now there are two ways in which this particular model can be used. We first discuss the multinomial way. So attributes in the multinomial ways are the text positions. So values are the words. So now we have to multiply each of the probabilities. Let's say a document contain x1, x2, and so many 100 words. So probability of each of 100 words, so that will be multiplied. So this is likelihood that will be multiplied of each of the word in the document. Suppose there is word our, text, so all the words probability is multiplied, then multiply with the prior for each class. So in this way we will get this value for Cj, that is if j is equal to 1 for C1, if j is equal to 2 for C2 and C3 and so on. Then we pick up the maximum value of that class. So prior into likelihood, and likelihood is also multiplication of probability of each word of that particular class, and that would be multiplied together. Is it clear? ये सबको clear है? आंचल, सिमरन, ईशानी सबको clear है? सृष्टि?
Yes, sir.
So this is the basic step, because learning we have learned these values likelihood, and then we have learned the prior as well. So here this model we are considering existence of word. We are not taking where that word is there. We are not looking at location of the word, but just the whether word is present or not. So still there are so many possibilities, because your document may have more than 100 or 1000 words, and and we are using the same parameter for each position. So that's why this is also called the bag of word model, because we are considering document as just a bag of word. We are not considering their location. So just like the words are present there or not. So that is why this is also popular as a bag of word model. So in this, we are just looking at whether word is present or not. And if it is present, then we are multiplying with its corresponding probabilities. So now learning from the documents from training corpus. So we extract the vocabulary, we calculate the priors. So we calculate these probability of each words. So as I told you, this alpha in the last slide I told you to taken to 1, but you can vary this as well. And this I told you taken to be k, but again this again depends on the your vocabulary. Now, the position all word in the current case we are considering to be same. So we are not considering the positions, but if we start taking positions for each word, then we have to multiply with these probabilities. The total training time of model is what we are learning is prior, and what we are another thing we are learning is the likelihood for each word. So likelihood for each word is number of words are the number of words in the vocabulary. So this is represent the number of words in the vocabulary, and this is the number of classes. So one thing is we need to learn for each word, let's say if number of words are V, and for each class. So this is one part, and then for prior, So total number of documents on an average number of words. So this is the total length of the document that we are assuming that for each document we have to spend this much training time. And during testing, we have the length of the document average length, and for each class we have to calculate the number of words we have to multiply, and that is the total time taken for the testing. So testing time is less, training time is more, and obviously this is to be done offline, so it won't matter, and this is done online, but still it is very less as compared to the many other learning algorithms. So still testing time is less. Now, as I told you that when we multiply these values, when we multiply these probabilities, so there are chances that floating point may underflow. So lot of floating point values when you multiply, because there may be 1,000 words. So we have to multiply the probability of each of these. So one solution is take the log of these probabilities. So when we take the log of these probabilities, when we take log of full, so earlier what we were doing is we are multiplying this prior PCJ. So this prior multiply with multiplication of all the probability of each word in that particular class. So when I take the log, so this also become plus, and this product become the summation. So now this is not simple maximizing a posture here. So what we are looking at, this term is now called the log likelihood. So this you will in your machine learning you will this term is used many times. So log likelihood is, so likelihood is the probability of occurrence of something. Log likelihood is the log of something. It is not going to affect our final answer because we have taken the log for each of the class, and log is the that function for each class. Now we are looking for the maximum log values for each of these. So this would help us to reduce the this floating point underflow. Now we need not to multiply, just to add these probability log of these probabilities. So that would eventually help us. ये clear है सबको? दीक्षा, साहिल, सबको क्लियर है? Any doubt till
Yes, sir.
so these technologies you need to be very clear. Log likelihood क्यों लेते हैं? Why it is taken? So this should be very much clear to you. So now the naive Bayesian classifier, it is called naive because we have taken each words are independent of each other. We are not considering their positions. Position means location in the word, location in the document. We are just taking as a bag of word model. So now rather than multiplying, we are adding the logs. So each conditional parameter, conditional is whether that probability of that word to be present in that class is a weight that indicates how good an indicator of xi for Cj. Prior is the weight that indicates the relative frequency of Cj. That is, what is the chances that that particular class document can belong to that class. And this overall is gives the naive Bayesian classifier. So we have seen that its implementation is very easy. You can even once you got a data, you can easily implement it. So there are two models which are used for implementation. One is called the multivariate Bernoulli model, and where one feature is each word in the dictionary. Suppose you have 7 lakh words in the dictionary. So your feature vector size is equal to these 7 lakh words. So similarly, you might have seen there are model used by Google, that is glove model, or even the new model GPT-2. So they are very large. They are in billion parameters they are using. Billion, their vector size is in billion. So, but normally if you take each word in the dictionary, so then your feature vector is just the size of that. So your document will represent one if that word is present there, So since feature vector size is the size of your dictionary, so if word is present in the document, it is 1. If it is not present, then it is 0. So given a document's topic, appearance of one word in the document tell us nothing about that another word appears or not. So still it is a bag of word model, and we are using binary independence model is because whether one word is present, it never tells about the another word. It's just 1 or 0 values. So that is why it is very simple model to implement. The model 2 is a multinomial class conditional unigram model. So where for each word position in the document feature value. So feature vector is the number of position in the document. So first position. So this is the first attribute. Second position is the second attribute. Third position is the third attribute. So value of x is the word in the position I. सो लास्ट वाले मॉडल में क्या था, पहला एट्रीब्यूट जितने डिक्शनरी में वर्ड्स है उतने फीचर वेक्टर का साइज था. अगर 7 लाख वर्ड थे तो 7 लाख फीचर वेक्टर का साइज है. इस मॉडल में क्या है, जितने पोजीशंस हैं डॉक्यूमेंट में, सो डॉक्यूमेंट में अगर 1000 पोजीशन है तो 1000 साइज का वेक्टर है, और पहली पोजीशन पे उसकी वैल्यू क्या है, जो वर्ड एग्जिस्ट कर रहा है उसकी वैल्यू, दैट इज द वैल्यू ऑफ दैट फर्स्ट पोजीशन. सो इस तरह से फीचर वेक्टर इसका डिफरेंट है, एंड फीचर वेक्टर ऑफ लास्ट इज डिफरेंट. And naive Bayesian assumption is given a document's topic, word in one position in the document tell us nothing about the word in other position. So ये naive Bayesian assumption के कारण we can multiply the position that even though you know that this is not true. Word in one position in the document usually tell us about the next word. That's why because of these things recently deep learning has gained popularity. So naive Bayesian में ये assumption रहती है कि पहली पोजीशन पे कौन सा वर्ड है वो फीचर वेक्टर में वो एट्रीब्यूट है, दूसरी पोजीशन पे कौन सा है वो जो वर्ड है वो उसका एट्रीब्यूट की वैल्यू है. सो पहले मॉडल में वी आर जस्ट लुकिंग एट कि वर्ड प्रेजेंट है या नहीं है, 1 और 0. इस वाले मॉडल में लोकेशन वाइज इंफॉर्मेशन आएगी आपकी. सो वर्ड अपीयरेंस डज नॉट डिपेंड ऑन द पोजीशन. दिस इज आल्सो assumption taken for all the position of word W and class C. So that's why these models are very simple models. They do not concerned about the language, their context, the meaning, semantics. Nothing is taken. Only in the first model whether the word is present or not. In the second model, based on the location, at a particular location, which word is present. So only these things are taken care. So no meaning is taken care. So that's why naive Bayesians are the very much statistical models. ये क्लियर है सबको? जुनैद, श्रुति, साहिल, सबको क्लियर है?
Yes sir.
So let's apply this model on this data set. Let's say मैंने एक बड़ा छोटा सा डेटा सेट लिया, 4 ही डॉक्यूमेंट है, और हर डॉक्यूमेंट में ये जैसे पहले डॉक्यूमेंट में सिर्फ 3 वर्ड्स हैं, 4 में से 2 ही क्लासेस हैं, C1 and C2. C1 is China and C2 is not in China. सो 3 डॉक्यूमेंट तो बिलोंग करते हैं भी क्लास चाइना को, एंड 1 डॉक्यूमेंट इज नॉट चाइना. सो लेट्स से इसी छोटे से मॉडल पे हम लर्निंग भी करके देखते हैं और अपना मॉडल रन करके देखते हैं. ठीक है, सो ये आपका ट्रेनिंग डाटा है. तो फर्स्ट थिंग इज यू हैव टू कैलकुलेट द प्रायर. प्रायर इज प्रोबेबिलिटी ऑफ चाइनीज. So you have to calculate for each word. हर वर्ड के लिए आपने कैलकुलेट करना है कि चाइनीज वर्ड जैसे है, जो आपकी वोकैबुलरी में जितने वर्ड्स हैं उन सब के लिए आपने ट्राई करना है. सो आपकी वोकैबुलरी में वर्ड्स कितने हैं टोटल? सो यू लुक एट द क्लास चाइना. सो चाइनीज, बीजिंग चाइनीज, सो शंघाई, मकाओ, टोक्यो, जापान चाइनीज. सो नंबर ऑफ वर्ड्स जितने भी आपके हैं, so number of, so that is will be taken, वो आपकी vocabulary का साइज होगा. रिमेंबर आपको मैंने बताया था कि एक हम न्यूमरेटर में 1 ऐड करते हैं और डिनोमिनेटर में हम k ऐड करते हैं. तो वो हमने ऐड किया हुआ है। अब प्रोबेबिलिटी ऑफ चाइनाज इन क्लास सी, चाइनीज कितनी बार आ रहा है? 1 बार, 2 बार, 3 बार, 4 बार, 5 बार। सो 5 बार चाइनीज आ रहा है। सो प्रोबेबिलिटी ऑफ चाइनीज इन क्लास सी, क्लास सी मतलब चाइना, सी इज चाइना, तो चाइना में 5 बार आ रहा है। सो दिस वन इज एडेड टू अवॉइड जीरो प्रोबेबिलिटी। नाउ डिवाइड बाय द टोटल नंबर ऑफ वोकैबुलरी साइज। सो टोटल नंबर ऑफ, सो जो 8 जो 6 है, सो टोटल वर्ड्स कितने हैं चाइना में यस वाली क्लास में? सो टोटल वर्ड है 8 वर्ड है, 3 3 6 2 8। सो टोटल वर्ड्स 8 और वोकैबुलरी डिफरेंट वर्ड्स कितने? 6 आर द डिफरेंट वर्ड्स। सो चाइनीज, बीजिंग, शंघाई, मकाओ, टोक्यो, जापान, 6 आर द डिफरेंट वर्ड्स। So this is the probability of Chinese given class C. We will calculate probability of Tokyo and probability of Japan, दोनों की same है because both are not coming here. So 0 आएगा, 1 ऐड कर दिया to add 0 probability, denominator same है. So this is the probability of Tokyo and Japan given in a class C. Similarly हम probability of Chinese not class C उसमें भी देखते हैं। तो इसमें 1 बार आ रहा है, 1 ऐड कर दिया टू ऐड 0 प्रोबेबिलिटी। 3 टोटल वर्ड है नॉट क्लास सी के, सो 3 वहां से आ गया। 6 इज द वोकैबुलरी साइज, सो वोकैबुलरी साइज आ गया। एंड सो दिस गिव प्रोबेबिलिटी ऑफ चाइनीज इन नॉट क्लास सी 2/9। सिमिलरली प्रोबेबिलिटी ऑफ टोक्यो एंड जापान दोनों 1 बार आ रहे हैं, सो दैट इज आल्सो सेम। So is this part clear to you, to everyone? ये कैलकुलेशन क्लियर है सबको?
Yes, sir.
कोई डाउट हो इसमें कुछ? नाउ इसके साथ साथ हमने प्रोबेबिलिटी ऑफ क्लास सी भी फाइंड आउट करनी है। टोटल 4 डॉक्यूमेंट है। प्रोबेबिलिटी ऑफ क्लास सी इज 3/4, प्रोबेबिलिटी ऑफ नॉट क्लास सी इज 1/4। ये भी हमें पता चल जाएगा। नाउ वंस वी गेट द टेस्ट सेट, अब हमने प्रोबेबिलिटी देखनी है कि D5 यानी कि ये 5th किस C को बिलोंग करता है कि नहीं करता। तो पहले तो हमने प्रोबेबिलिटी ऑफ क्लास C जो हमने देखा 3/4 उससे मल्टीप्लाई किया है। फिर हमने चाइनीज 3 बार आया था, चाइनीज की वैल्यू 3/7 है। सो प्रोबेबिलिटी ऑफ चाइनीज इन क्लास C ये 3 बार आया है, वो मल्टीप्लाई हुआ है। फिर टोक्यो, सो टोक्यो की 1/14 है, जापान की 1/14 है। इन सबको मल्टीप्लाई करके वी गेट दिस वैल्यू। अगेन इसी की प्रोबेबिलिटी ऑफ नॉट क्लास सी D5। सो प्रोबेबिलिटी ऑफ नॉट क्लास सी ये भी हमने देखा कि 4 में से एक ही डॉक्यूमेंट था, सो 1/4। प्रोबेबिलिटी ऑफ चाइनीज 3 बार आया है, इन नॉट क्लास सी 2/9, सो ये वैल्यू आ जाएगी। एंड फिर टोक्यो और जापान की, सो दिस वी विल गेट। सो वी गेट द प्रोबेबिलिटी ऑफ बोथ ऑफ दिस। Here in this example I am just multiplying, but as I told you कि हम वैसे log लेके करेंगे। I am just for easy purpose, so I am just multiplying these things. ये clear है सबको? Is it clear to you? साहिल, विपाशा, जुनैद, clear है सबको?
Yes, sir.
So now we can see that अगर हम बाइनरी अकरेंस के साथ, अगर हम उनकी पोजीशन के साथ चलें कि हाँ अगर हम मॉडल को थोड़ा सा चेंज करें, सो डिनोमिनेटर्स में आर टेकन की भी यूनिकनेस के साथ अगर हम चलें कि कितने यूनिक वर्ड्स हैं और टोटल नंबर ऑफ डॉक्यूमेंट्स के साथ चलें। सो पिछले केस में मैंने नंबर ऑफ वर्ड्स लिए थे यहाँ पे डिनोमिनेटर में, एंड जो फॉर ईच टर्म अकरेंस एंड नो अकरेंस के अगर मैं थोड़ा सा मॉडल चेंज करूं, सो डिनोमिनेटर मेरा चेंज हो जाएगा। और अगर मैं यूनिक अकरेंस ही उसकी देखूं भी वर्ड में, पिछले केस में मैंने टोटल अकरेंस देखी थी कि 5 बार आ रहा है, बट अगर मैं सिर्फ ये देखूंगी हर डॉक्यूमेंट में आ रहा है या नहीं आ रहा है, तो थोड़ा सा मॉडल चेंज हो जाएगा। सो पिछले केस में जहाँ पे 5+1 कर रहे थे न्यूमरेटर में, क्योंकि चाइनीज 5 बार आ रहा था, अगर मैं बाइनरी अकरेंस देखूंगी, सिर्फ ये देखूंगी भी आ रहा है या नहीं आ रहा है, डू नॉट काउंट दैट नंबर ऑफ टाइम इट अकर, तब ये वैल्यू चेंज हो जाएगी, तब थोड़ा सा मॉडल चेंज हो जाएगा, ये सारी वैल्यूज थोड़ी चेंज हो जाएंगी, बिकॉज आई एम नॉट काउंटिंग द नंबर ऑफ टाइम इट इज अकरिंग, बट जस्ट बाइनरी कि आ रहा है या नहीं आ रहा है, तब ये थोड़ी थोड़ी वैल्यूज सारी की सारी चेंज हो जाएंगी, और ओवरऑल कैलकुलेशन में भी थोड़ी सी चेंजेस आ जाएंगी। बट अगेन वट एवर बेस पे, अगर पिछले इफ वी गो टू लास्ट स्लाइड, सो टेस्ट सेट में क्या आ रहा था कि ये डॉक्यूमेंट इट बिलोंग्स टू द चाइनीज, भी सी क्लास चाइना को बिलोंग करता है, बिकॉज इसकी वैल्यू ज्यादा है, प्रोबेबिलिटी ऑफ सी इज वैल्यू इज मोर, सो दिस डॉक्यूमेंट बिलोंग टू सी चाइना। Now in next case, so Chinese, Tokyo, Japan. So here the value of not class coming out. So here अगर मैं थोड़ा सा बाइनरी occurrence के अकॉर्डिंग चलूं, now in this case this class belong to not China, क्योंकि इसमें टोक्यो जापान आ रहा है, और टोक्यो जापान किसी भी चाइनीज डॉक्यूमेंट में नहीं आता, तो यानी कि थोड़ा सा मॉडल में अगर चेंज करते हैं तो आउटकम चेंज हो जाती है। और इसमें और पिछले मॉडल में जस्ट यही चेंज किया है कि इसमें अकरेंस एक बार ही काउंट किया है, नॉट कि टोटल नंबर ऑफ अकरेंसेस, ओनली बाइनरी अकरेंस काउंट किए। ये क्लियर है सबको?